Hi there, in this video we're going to demonstrate one of the examples of 3D extrusion using the materials processing workspace inside ANSYS Fluent. So what we're aiming for, as you can see here, this is the result of an extrusion simulation carried out using materials processing in Fluent. We've got a simple die here and you can see the extruded material exiting from the die. Okay, so a typical objective of this kind of simulation would be to see the shape of the extruded material. So we'll start from scratch. I'm going to open up a new Fluent session. Now, if you've not used workspaces before in the launcher, typically you'd be on meshing or solution. They're just below there. So if we pick materials processing, and we'll start up the Fluent session. So that's going to open up in a slightly different version of the interface. And what you've got here is essentially the polyflow solver, which is embedded into the Fluent interface for polyflow specific types of simulations. All right, so the first thing that we do is import a mesh. You can see there's two options here. You can import a Fluent mesh, although polyflow is not compatible with the polyhedral cells. So I'm going to select polyflow mesh. Generally then we would be generating these meshes using ANSYS meshing. As an example here, we've got a similar geometry. Once you've meshed that, you can go to File, Export, select Mesh, and you see you've got an option there to export the polyflow input file. Okay, so let's import the mesh. It's bringing up a dialog box here. It gives me the domain extents, and it's asking me for a mesh length unit. Okay, in this case it's centimeters. Right, that's going to bring in the model here. You can see in the outline view it does set up some display objects here. The outline, they're there for you. When we start this simulation, you can set everything up manually, but there are a couple of features here under Setup Simulation. We've got something called a wizard and a template. They both set up most of the elements of the simulation process for you so that they insert all of the right tasks in the outline view. The template is a little bit more flexible, so we're going to use this one. And you see it asks me for the type of simulation. All right, so we've got three options here: internal, extrusion, pressing. So I'm going to pick extrusion. We've now got a number of other options: the goal or the intent of the simulation, and we're going to be interested in predicting the shape of the extrusion. Okay, and we can specify a number of fluids. In this case it's a single fluid, and whether or not we want to take into account thermal effects, and in this case we're going to leave these switched off. So once I press apply, you can see it's populated the outline view here with all of the tasks or objects that I need for this type of simulation. It's also highlighting which of these tasks require input. Okay, so we'll start from the top. Just look at the materials here. We've got a default fluid in here, and we can view all of the properties, make changes should we need to, or alternatively you can import a fluid from the built-in library. And you can see we have families of fluids here. We can pick extrusion, and then you have a number of examples of materials that you can use for an extrusion simulation. Okay, in this case we're going to use the default fluid, but we're just going to make some changes to the settings of the viscosity law here. You can see these are all the different viscosity laws. Okay, I'm going to pick the cross law. I'm just going to put in my properties here. Okay, so moving down to the cell zones, if we pick the fluid zone, it's essentially asking me for me to identify the cell zones here. We've only got two. We've got subdomain 1, which is the die, so that's this bit here. And then we've got subdomain 2, which is the part that actually represents the extrusion. Okay, and the remaining options, we can choose the fluids model here, multiple materials if relevant, and then the fluid materials, and that's already selected. We just have the one material here. So we can move down to the boundary conditions now. And if you click the parent object here, it does give you some guidance as to what actually needs doing. Okay, so if I'm just going to run through the 4 boundaries here, and again it's highlighted, simply a case of selecting the correct boundaries. So if I click on boundary zone here, so this is the exit, all right, so the extrusion is going to exit from this boundary. Just select that. Then we have the free surface. Okay, and this is, yeah, it's a quarter symmetry model. Okay, so this boundary here is what we're actually modeling, and these ones here, they're the symmetries. All right, so for the free surface, it's this one. You're selecting graphically, you do have to have the dialog box open. So I'll pick that. Then it's asking for the fixed part. So this is the part of the free surface which is constrained by the wall of the die. Okay, so that is this boundary here. Okay, we'll move on to the inlet. This is straightforward. This is the inlet face. Then it's asking for the inflow condition or type. So you can see we have a number of options here. So I'm going to go for volume flow. Okay, put in the flow rate, just make sure you check the units there. And then it's asking for the wall boundary. So that's the wall of the die, which is this zone here. All right, open the dialog box. The correct zone. Okay, you see it's still highlighting that I've got some other things to do. So if I just click there, it's just flagged up zones which have no assignments. All right, so that's these 4. So this is the symmetry zone. So all I need to do, if I click new, it creates a new boundary for me. Just give it a name, assign the type, and then pick the zones. So I'm just going to control select the 4, click OK. You can see now that the parent task there has got the green check mark indicating that that setup is complete. We'll move on to the next task now, which is mesh deformations. Okay, so this controls how the extruded material is deforming the mesh. So firstly, we have to select the zone that's actually undergoing the extrusion and deformation. So that's the zone on this side here. Okay, I've named that subdomain 2. Okay, next it's asking for the inlet to the part which is being extruded. All right, so if I select this, you can see that once I selected that, the fixed part of the simulation here, so that was subdomain 1, which is representing the part that's inside the die, that's disappeared. So the inlet that it's asking for is actually the interface between those 2 zones. Okay, so I select this one, and then the outlet selection, that's straightforward. It's just over this side here. All right, the next consideration here is the deformation method. There's a number of different methods here, depending on what you're doing in the simulation. These determine how the mesh nodes are deformed. Okay, now for cases where you've got an extrusion which is planar or aligned to the ANSYS system, then the Optimesh 3D is recommended. Okay, but there are alternative methods there which are recommended for slightly different scenarios. All right, so having done that, we're now ready to proceed to the solution calculation. Just before that, though, there's a couple of things that I should mention under the solution outline view here. So firstly, under calculation activities, Polyflow is, as I say, a different solver to Fluent. It's an FE solver, so it doesn't scale in the same way. You can enter the number of processes that you want. For a small case like this, I'm just going to leave that to the default, but it's something that you'll have to try on your own cases. Okay, next I'm going to look at the outputs here. So you can see that we've got various options for different types of post-processors. And I'm going to look at derived quantities here as well, because when you do a polyflow solve, you have the choice between, just as in Fluent, you have the choice between what data that you actually want it to output here. So there's additional fields here that you can calculate. So just as an example, I'm going to say, okay, let's have residence time. We'll check that one. Okay, and it's asking for the inlet boundary here, so it can calculate the residence time for me. Additionally, we've got the monitors here. Okay, so typically your two convergence monitors, we'll leave those checked, and then we can move to the run calculation. Now, before you run a calculation in materials processing, it's a good idea just to run this check, and that's just going to run through the process and flag up any setup issues that you might have. So in this case, everything's fine, and the solver can be started. All right, so we'll press calculate. Now, as it's calculating, it's reporting what it's doing into the transcript here. So that's this button here. So if there are any problems in your simulation, then generally that's going to be described in the transcript. You can see in this case, it was a very quick simulation, and you can see it's telling me the computation has ended, and we've got the results. You can see here that it's already displayed the outline, and you can see the shape of the extrusion. Okay, so if we go down to results here, from now on it's simply a case of post-processing, very much the same way that you would do in Fluent. So you can see we've got a default mesh objects here. You can see how the mesh has deformed. So let's just create a quick contour here, just by way of example. Choose the field. So we've got our basic output fields here, and if you remember, we asked for an additional derived quantity, which was residence time. So let's put that one in there. Okay, and pick the surfaces, and yeah, I'm just going to pick all of them here, and then display. Okay, so that's the complete simulation. As I say, from this point, it's just a case of post-processing, a demonstration of a simple 3D extrusion using the embedded polyflow solver inside the Fluent materials processing workspace. Hope you found this video useful, and thanks for watching.